Welcome to a quick demo of the tree detector block from Spacept. I'm Sergio, and in a few minutes I'll show you how to run the block, starting from scratch. So if we go into Marketplace and select the block, we can read the documentation, and then in order to use it, we can simply click on Use Block. And that will take us to the project space. Over here, I'll create a new project for the purpose of this demo, and I'll name it like this. And within the project, we can create a workflow that will contain the data as well as the processing blocks needed for the job. We want to inspect an area in Paradise, California for vegetation management, for example, because we know that before technology like ours existed, it was hard to inspect remote areas and prevent forest fires due to power lines that are close to growing vegetation. We'll add a raster tiling block in order to speed up the process. This essentially splits the incoming image into multiple raster tiles that are then fed into our deep learning tree detector model. Finally, we can add the tree detector itself. And by the way, the raster tiling block is only needed for large areas. Now we can save and configure the job. And if we don't already have an area of interest that we can specify, we can select it from here. So let's go to Paradise, California. Let's see, if we zoom into this area, for example, it should have quite a few trees. It's also important to note that we gotta pick images in a time that the trees are in full foliage in order to really see them as best as possible. And we should also pick images with a low max cloud coverage. And by full foliage, we mean during the late spring, summer, or early autumn. Then we have the raster tiling block, followed by the tree detection algorithm. And here is an estimate of the total cost required to run this analysis. Up42 comes with 10,000 credits freely available for newly created accounts. After running a quick test job to see that the images are available in that area, we can run it as a real job. The block can be used in forested regions, in cities, as well as alongside infrastructure points to carry out inspections or for forest management purposes. We see that the images have already been downloaded, and I will open them in a new tab and extract the archive generated. I recommend using 7-zip when extracting files, because on Windows at least, WinRAR seems to give compression errors from time to time. And in QGIS, I will open this image that was newly downloaded. So this is the satellite image that has not been processed yet, and the tree detection analysis has been completed as well. And I will download it in a new tab and perform an extraction of it as well. That will allow us to visualize the images side by side. And there we go. These are the images that have been generated. And you can see the brightness associated with the tree, like the likelihood of it being a tree. Fluctuating between the two images, we can see the overlay of the tree's detection. For example, this green area that is perhaps a lawn or a puddle, it is not falsely labeled as a tree. It is not triggering the annotation at all, whilst the trees are doing that. Now, thank you for your attention, and we're happy to answer any questions that come along. Just drop us a line at hello@spacept.com or via up42. Thank you, and enjoy using the blog.